So now we're going to do an example of a Hess's law problem. You'll notice you're given three equations and you know the value of the delta H, and we want to find the delta H for the top equation. If you want to work that out a minute and try it, pause the video. I'm going to go through the solution here now. So this is what I want to find the delta H for, this guy right up here. What I need to do is manipulate equations 1, 2, and 3 so that when you add them together, it looks like the top equation. So what I would suggest is looking at my answer. I know I need a carbon disulfide as a reactant with a coefficient of 1. In looking at equations 1, 2, and 3, the only one that has carbon disulfide is right here. It's not a reactant. It's a product. So what I need to do is take equation 3 and reverse it. So I'm going to write my products as reactants and the reactants as products. If I switch the equation, then I just need to change the sign of my delta H. Positive 87.9 becomes negative. That takes care of equation 3. I can't mess with that anymore because that's the only one that has the CS2 in it. The next one I'm going to look at is oxygen. And the problem is oxygen is in 2 equations, so I really don't want to deal with that if I don't have to. So I'm going to skip it for now. We might have to come back to it. This guy here, CO2, when I look at it, the only equation that has CO2 is the first one. It's on the reactant side like it needs to be. It's got the correct coefficient, so I don't have to do anything with that first equation. So I'm just going to rewrite it. Carbon plus O2 produces CO2. And I didn't change the delta H, so it still is going to be negative 393.5 kilojoules. And that takes care of my first equation. The last substance is SO2. And the only equation that has SO2 in it is the second one right here. It's on the correct side. It is a product, however, it's not, or does not have the correct coefficient. So all I need to do is double everything in that equation to give it a 2 like I need right there. So doubling the second equation means I have 2 sulfur plus 2 O2, and that produces 2 SO2. Well, if I double my delta H, I need to double this one as well. And when you double that, negative 296.8 times 2 becomes negative 593.6. Hopefully, since I've worked with all 3 of my equations, when I add these guys together, my net equation equals what it's supposed to up here. So let's double check. I'm going to compare everything I have on the left and see if I can cancel anything out. It looks like I've got a carbon on the left and a carbon on the right, so they're gone. It looks like I have 2 sulfurs on the left and 2 sulfurs on the right, so they're gone. And it doesn't look like I can cancel anything else out. So what I'm left with on the left is a CS2 plus 2 plus 1 is 3 O2s, producing 1 CO2 and 2 SO2s. And if we compare, that is exactly what the equation says. So I know I did it right. To find my delta H for the equation, all I have to do is add those up. And I got a delta H of negative 1,075 kilojoules, negative 1,075 kilojoules for that example.